we have finally made it to the second system, the box whisker median IQR. We're going to learn how to make a box whisker plot, and to do that we need a 5-number summary. Here, let's get to the question. We're going to go back to our how much yak cheese can the yak produce per year. Same data as before. We talked about these two systems. Right, we've done this one. We're good. Now we're doing this one. Right, so let's clear out this side a little bit. Now, in order to make the box whisker plot, we need this thing called the 5-number summary, which ironically has 5 numbers. The first thing we have to do is actually sort the data into ascending or descending order. Let me show you quickly how to do that on your calculator. Over here we have our data. You see, I've already put it into L1. Something that maybe I should show you, I got some random data in L2, L3. That's a little annoying. How do I clear a list? Notice that I'm up on the header, L2. I can hit clear. Notice that down here, all the numbers disappeared. And all I have to do is hit the down arrow or enter. I could go to L3. Notice we have all these numbers down here. I clear them, but it doesn't take until, and I guess I could probably hit enter as well. There we are. So now in order to sort a list, and let me show you something else cool. If I wanted to copy this list over, again, I'm up on L2. All I have to do is go second L1. Notice that I'm saying L2 is going to equal L1, and it's just going to copy the list over. Now, sorting it actually happens outside of the stat lists. There we go. If we go to stat, and you'll see here, there's sort A and sort D. This is sort ascending, sort descending. Usually I like to sort in ascending order, and maybe I'll sort actually that second list, L2. They're identical really. And now we can look at them. And here we have the sorted list, just like I have here. So that's a convenient way to sort lists and copy and clear and some other things. So we have the first number in our 5-number summary is the minimum number in the data, which in this case is 0. One of the other numbers, the 5th number really, is the maximum, which in this case is 76.4. Now we need the middle. We need the middle number, which you can see we are going to use the median for the center. Median is the geometric middle of the ordered list. So how do we get the middle? Now we could probably just sort of, do hash marks and do that. If we had, 2,000 data points, we need some better method of doing that. So of course we have 18 numbers. If we want the middle, shouldn't we just divide it in half? And that should make sense, except that there's some issues that we have to be a little bit careful about. Here's the 9th number. Is this the middle, the geometric middle? What's the geometry of this situation look like? Right, well, yeah, both halves have 9 numbers in them, but if we use 36.4 as our middle point, is it symmetric around that middle point? And the answer is no, not really, because how many numbers are above and below? Well, there's 8 numbers above, but 9 numbers below. It's not symmetric, so that 36.4, the 9th number, is actually not the median because it doesn't divide it geometrically. So what do? Well, solution is to make a middle pair, because now we have 8 numbers above and 8 numbers below, and it's now been divided geometrically. But we have 2 numbers, a middle pair now. So what do we do with those? Well, we end up actually finding the mean of the middle pair in order to get the median. It's a little ironic that. So the median turns out to be 36.7, which I'm going to move over here. So that's the middle. Now what we want, the last 2 numbers are the first quartile and the third quartile. We have half of the data up here. If we cut this half in half, what does that make? Well, it makes quarters, right? Those are quartiles. So we really just repeat this process of the median for the upper and lower halves, and we find the middle points for the upper half, which is the first quartile, and the middle point of the lower half, which is the third quartile. The median technically is actually the second quartile. So it's first, second, third quartiles, although we use the word median for that. So what we end up doing is saying, all right, if we were going to do this using a very formulaic approach, we could just say, all right, whatever this is, we divide that in half. We get 4.5. Well, is there a 4.5 number? No. So we go up to the fifth number, and notice that that does divide this evenly. There's 4 numbers above, 4 numbers below, and that is our first quartile, which is 26.5. We do the same thing with the lower part, and that gets us our third quartile, and those 5 are now our 5-number summary, which means we can start actually drawing the box whisker plot. We need some space. Let's clear out that, and let's clear out that. The first thing we need is a number line. The number line needs to contain all 5 of the 5 numbers, so 0, 76.4, so I go from 0 to 80. And all I have to do is plot those numbers. I usually plot them not on the number line, but above. Now, the box of the box whisker plot is defined by Q1 and Q3. The median is just a vertical line somewhere inside that box. The whiskers go from the quartiles out to max and min, and we have our box whisker plot. There it is. Now there's 2 ways of drawing it. This is a horizontal box whisker plot. You can actually do it vertically, which will look something like this over here. A point at which you should be a little careful of. This is a number line. It's like the y-axis. It's not actually a y-axis, but you start low and you go up. Positive is up, negative is down. Sometimes, for some reason, students flip that around. So we have a vertical box whisker plot. We can also now get our IQR, which is our interquartile range, and that's our measure of spread for the box whisker system. And that's actually a pretty easy calculation. It's actually just Q3 minus Q1, which in this case turns out to be 20. And that's the width of the box. That's your IQR. Something we can also talk about is range, which is max minus min, which in this case is 76.4. Now, actually, range can apply to not just box whisker plots. You can actually talk about range with the histogram system as well. Didn't really talk about that before, but you can. So let's go to another question. What is the temperature like in Manitoba, Canada during January? Right, so we collect a bunch of temperature measurements. We have 19 of them. Right, we of course have to sort them, which looks something like this. We have to find the middle, which we'll start with the middle anyway, the median. We have 19 numbers. Right, we divide it in half, 9.5. We don't have a 9.5 number. Right, so what number is actually going to create symmetry? And that's going to be the 10th number, because it looks something like this. So the median would be negative 11. Now, something to do a little compare and contrast. Remember, the first example looked something like this. It looks actually a little different, right, because this negative 11 is actually not part of the lower or upper parts, right, where here every number in the data set was actually used for the quartile calculation. Right, so it just depends on, this is an even numbered list. There were 18. This is an odd numbered list. It's 19. And so it looks a little bit different. But the underlying concept of creating symmetry and quartile would be half of the upper part, half the lower part. It just depends on what is upper and lower. Right? Notice in both cases, the median is not included. Here, 36.7 is in neither above or below, right? Because actually it's not one of the numbers at all. And here, this negative 11, this median, is in neither the part above nor the part below. So in that case, that's consistent. It just looks different depending on whether it's an odd or even numbered list. All right, well, let's get back to getting our 5-number summary. Let's divide the halves in half again, 4.5. And of course, there is no 4.5. So we always go up. I mean, something that I think about is, to make it a little bit easier, is you always go up. Right? If you have a decimal number, you just go up to the nearest whole number. Remember, in the first example, we had the 9th as our median. And we went up. We used the 9th and 10th. So if you get a whole number when you divide, you use that number and the one above. If you get a decimal when you divide, you just use the one above. But you're always sort of going up. So we are going to use the fifth number in both of them, which turns out to be the -16 and -9. That's our quartiles. Max and min, of course, are right there. And we can draw our box whisker plot and get our IQR. And, we're more or less done. Now, something that I should probably show you to make your lives easier, because my job is to make your lives easier, is all of this whole box whisker plot can be done on the calculator, right? Just like histograms can be done on the calculator. So I'm going to use the first example to run through on the calculator. So the first example is an L1. There we go. Yep, that's the data. I was concerned there for a moment. Maybe I'll just clear this because you don't have to sort it. The data is just an L1. And then from there, so a few things to show you. First of all, let's quit out of this. Our data is in L1. So now, remember I showed you over here in calc, stat calc, right, 1 var stats. Let's do 1 var stats for our data. And remember this little arrow I showed you meant you could scroll down. And now these numbers, which you didn't really know what they meant before, right, notice that this is your 5-number summary. All right, so the 1 var stats gives you your whole 5-number summary, which is super nice. But let's actually make the box whisker plot. So what we need to do is go over to stat plot. Right, we have our plot 1, which previously we had set up as histogram. So here we actually have 2 box whisker plots. One has little dots here and one doesn't. This is a modified box whisker plot. The dots are actually identifying if there are any outliers. The outliers would be the dots. This one doesn't worry about outliers. It just does the calculations without checking outliers. So we haven't talked about outliers with box whiskers. The calculation's a little bit different than for histograms. So let's just do this one. And it's still in L1. So now if I hit graph, there's my box whisker. And if I hit trace, right, here the cursor is in the median. It tells me what the median is. I jump over here. Here's first quartile, minimum, third quartile, maximum. And that's how you make the box whisker on the calculator.